Right, let's get this started. So this week we'll continue from our discussion last week. We talked about site planning processes last week, and over the next couple of weeks, talking about I'll be talking about site inventory and how to conduct site inventory, what you need to look out for, and what you need to keep an eye out for during site inventory to gather relevant data for site analysis and subsequently site planning. For this session, I'll just focus on mainly on site condition data, such as topography, geology and soils, climate and microclimate, and then natural hazards. Next week, we'll talk about other site conditions that you need to be mindful of, and I'll also talk a little bit about land use, bit about infrastructure, and touch on regulations and standards. So this is where we are at the moment. Last week I mentioned that the first of the initial stage of site planning, which includes programming and site selection. Let's just assume that we already have a site, an imaginary site, or maybe you guys have found a potential site to develop for this semester's main task. But this bit has been taken care of. We'll focus over the course of the next couple of weeks. We'll focus on building an inventory of the physical aspects of the site, some biological aspects of the site, and some cultural aspects, so the tangibles and the intangibles, before we move on to site analysis and so on. So when we talk about site conditions, we do realize we need to keep in mind that every site embedded within a landscape, and a key goal in site planning is to understand the site and its surroundings. That's one of the key goals. And then because we will take that understanding of the site and use it as a resource for redevelopment. So redeveloping a parcel of land requires a lot of information about the site, as well as the site surroundings. So not only your site, but what's going on around your site. Many site attributes, such as vegetation type and slope, they are unevenly distributed spatially. So you can make a list of vegetation. You can make a list of the different kind of slopes that is on the site or that make up the site. But you need to know, other than the list, the tabulation, you need to know where these items are on the site. Some attributes, such as seasonal temperatures and precipitation, they show very little variation at the site scale. When we normally when we represent climate data, um, we we talk about a regional or a citywide scale, um, temperatures and precipitation. Rarely do we talk about precipitation, temperatures at a site scale, unless of course you're looking specifically um, into climatic phenomenon within the site. Um, Although temperature and precipitation can vary, of course, throughout the year. This is especially so if you happen to be developing a site for in a four season area, four season country. Um, Temperature variations here and around the equator isn't so isn't so dramatic, so to say, isn't so drastic. But in the northern and the further south, in the further southern hemisphere of the globe, then yeah, things can be different. And the differences in temperature and precipitation throughout the year um, can affect the use of the site from season to season, and consequently, it may be appropriate to document the spatial distribution of a particular attribute at more than one time of the year. For example, if you have vegetation that turn different colors throughout the year as the seasons change, you might want to take a note of that, because you can use you can use that change to give your site an aesthetic appeal. Uh, I remember what what palace was it in Austria? Um, Schönbrunn Castle, Schönbrunn Palace in Austria. In Vienna, Austria, have a has a row of trees that change color throughout the year. So when I was there, when I was there mid year, in autumn. Sorry, in summer, it was all lush green. But when I came back there in September, I think it was in September, or was it in October? When it was fall, it was coming. We were coming into the end of fall and coming into winter. The leaves have turned. They're now all brown, and some of them have even started to shed their leaves. So you can use those seasonal variations in temperature, seasonal variations in behavior, whether it's vegetation or any other thing, and use it to your advantage. Um, so I just mentioned vegetation, but basically any site attributes that vary seasonally, which includes wildlife distributions, wind direction and speed, sun and shade patterns, and even groundwater levels. Those are a good thing. Those are good things to keep in mind. Um, and since site planning and design involve land use decisions affecting people, an understanding of human behavior and human attitudes and preferences is also necessary. Um, so, the site inventory is a focused process of collecting and mapping the spatial distribution of essential contextual information It is not exactly a fishing expedition or an open ended investigation of all biophysical or cultural phenomena that occur on or near the site. Um, the project program, although subject to several revisions throughout the project life cycle, as it is subject to revision as more and more site information becomes available. Helps to narrow the scope of this data collection effort. So, what do you want to develop on the site? What you want to develop on the site subsequently influences what kind of data you need from the site. So it's not like completing a checklist. Sorry, here you go, buddy. Come over here, buddy. You got the cable with you, power cord. Hmm. Okay, so moving along. One of the first tasks in the site inventory process is to develop a base map. Now, um, the base map ideally should contain the items that are mentioned in this table before you. Um, one of the reasons why we should prepare a base map in preparation is that it serves because the base map itself serves as a template for attribute mapping and analysis, as well as for subsequent site planning and design drawings. Um, if a topographic survey of the site is available, the base map will typically include project boundary lines and other surveyed information. Topographic surveys for site planning purposes are usually done by land surveyors according to specifications and according to specifications that are tailored to the program and the site. And the survey depth, as in the amount of attributes that you'd like to capture, is also dictated by the amount of resources that you have, i.e., your budget. Rectified aerial photos. I took this from Google Maps because that's the map that's the map that most people are familiar with. Um, Google Maps, if you switch on the satellite imaging layer, um, counts as a rectified aerial photo. And rectified, as I mentioned, rectified aerial photos are particularly good base maps to overlay your inventory. Um, and then if you take these aerial photos further, aerial photos and inventory further, you can still use them for analysis and then to develop conceptual design, graphics, and so on. One of the great things about Google Maps is that if you type in a location, the property boundary lines are quite visible, even if you turn on the satellite imaging layer, and you can also turn off other layers as well, so that you can filter out the information that you need and want. You can get rid of the labels, and that gives you a much clearer picture and so on. So um, a base map then should convey the the size and orientation of your site, and the size and the orientation of the base map itself, the scale, largely depends on the size and shape of your site. Um, you would rarely have a regular shaped site. You might have a site shaped like a chicken nugget, or you might have a site that is shaped like, oh, I don't know. Sky's the limit when it sky's the limit when it comes to imagination. So scale of the map depends largely on the size, shape, the complexity of the program, of course, and the importance of nearby off-site factors. Ideally, a single size and orientation are used consistently for the entire set of illustrative materials. So, for example, if you want to have, if you are to have a uh, 1 to 1 kilometer scale, say for example 1 to 1,000 scale, then all of the maps that you produce, all of the illustrative materials that you produce for the inventory analysis, base map inventory analysis, up to the final design, should be consistent with that scale, 1 to 1,000, or maybe 1 to 5,000, depending on the size, shape, and complexity of the site. You don't want to have a base map that is 1 to 5,000 and then an analysis of 1 to 1,000, and then because that would just be disorientating. So you need to be consistent with the map size and scale. Another thing to note is that maps and plans are normally oriented so that the north is at the top of the sheet. That just makes it for easier navigation, I suppose. The size of the base map is also a function of the map's scale. A land use planning project for a relatively large area, for example, several hundred acres, could conceivably have a relatively small scale base map, 1 to 200 or 1 to 400. On the other hand, a site planning project for a residential or commercial building on a much smaller scale, 1 acre or 1 hectare, could have a relatively large scale base map of 1 to 20 or 1 to 40. So because if you have a larger, bigger area, bigger, smaller scales, 1 to 100, 1 to 200, 1 to 1,000, and so on. But a smaller scale, then a smaller size or a smaller scope, then a larger scale base map, 1 to 20, 1 to 10, and so on. Although I wouldn't really, I don't think 1 to 20 is a scale commonly used, even in maybe in architecture and interior design, but for site planning, I don't think you go down to the tens. Anyways. The base map typically includes, you might have a clue already as to what the base map includes, but it includes, of course, existing conditions such as property boundary lines, public rights of way and easements, topography, buildings, streets and utility lines, both above and below ground, and of course adjacent property users and owners, if possible. So we're not only so it gives the audience, it gives yourself and it gives your audience a good illustration of what's going on in the site and what's going on around the site. The base map would also typically include ancillary information or supporting information, such as the site location, is a smaller scale map showing the site within its broader context. A title information. Title information usually contains project name, location, who the planners and designers are, who the consultants are, and so on. A north arrow, of course, for orientation purposes, and a graphic map scale, usually one of those line scales. And then lastly, data sources. When was the site surveyed? So the date of the site boundary survey, the name of the surveyor, and other source data. Now, since you're all taking the locational analysis unit this semester, I'm sure they will. I'm sure the good people in the unit will provide you with more information and on what you should include when you compile or when you compose a map, especially the block, especially the title block section, what should be in the title block section, and so on, and the format of the map. Yeah, again, I mentioned the word title block. A title block is usually situated either vertically onto one side or horizontally towards the bottom of the page. It is a common feature of construction drawings, not just geographical visual material, but in the title block, it usually includes project information. In this case, would be grading plans and planting plans. For site inventory and analysis, maps and conceptual plans, the title information can be presented in a far less structured format. And on the base map, you can use graphical symbols to convey information about existing site condition and proposed conceptual design. If you happen to conduct a direct site visit or a direct site survey, then you can use you can draw with these graphical symbols freehand and on site. So as you walk along, you dot as you walk along a path, you can dot your the lines on the you can dot your path. You can scribble barriers, constraints, or possible hindrances or possible possible or foreseeable issues. You can use polygons. To delineate districts, certain clusters of vegetation, certain clusters of objects, maybe, or use it to represent bodies of water and so on. So, yeah, but you can also you can still use these graphical symbols even if you're not conducting a direct site survey. If you're conducting an indirect or a remote site survey, then you can still use these graphical symbols and scribble these digitally onto your map. So once we got the base map more or less ready, we can start to consider other things. The first thing I would recommend to consider is the parcel size and shape. Now, land development and land redevelopment occur over a range of different site scales. A single-use commercial project, for example, can be designed and implemented on a site of less than a hectare. In contrast, a single-family housing project, multiple houses, may be planned for a site of 20 acres or about 8 hectares or more. Um, parcel size, land parcel size, is an intrinsic constraint on a site's development potential. If all other factors are equal, larger sites can accommodate more extensive and more diverse development than smaller sites. On smaller sites, off-site factors are more likely to influence the site's design. So, two or more contiguous parcels of land are sometimes combined to create one larger parcel, provided that those two parcels of land are under one ownership. Um, Larger sites generally allow greater flexibility in arranging program elements on the site. So if you have multiple components, if you're building, if you're working on a housing project of 1,000 houses, if you have a large site, then of 1,000 dwelling units. If you have a large site, then it gives you much greater flexibility in how you would arrange these 1,000 dwelling units. Maybe 200 large units, 500 medium size, um, and 300 small size, or vice versa, or whatever. But if you have a much smaller size site or parcel of land, then 1,000 dwelling units, you might think, well, I can't build them horizontally, so I have to build them vertically and whatnot. So that said, larger sites, more flexibility. Additional site area also allows for the integration of green space, including natural areas and new plantings to separate incompatible uses. You can also use vegetation to screen undesirable views off the site, and perhaps even filter and retain some storm water. So that's about size, but then the shape of the size can also reduce or influence development potential and design flexibility. This is especially true on smaller sites, especially sites that are narrow linear sites, and they have a higher edge to interior ratio than properties that are more compact in shape. The figure on the screen shows the relationship between parcel shape and edge to interior ratio for two parcels of equal area. So both these both these both these land parcels have have equal area. It's just that because they're shaped differently, on the linear or the elongated parcel, you have a 46% edge area and a 54% interior area, whereas on the more compact or the square site, you only have an edge area of 36% compared to a 64% interior area. A greater proportion of edge a greater proportion of edge area increases the site's exposure to surrounding landscape. So if your site happens to be adjacent to a busy highway, for example, a linear or a small site will substantially limit the site planner's ability to buffer traffic noises. However, if the site is adjacent to a natural amenity, a parcel with a relatively high edge to interior ratio will benefit from this spatial relationship, particularly if the amenity is likely to persist well into the near future. When you take shape and size in combination, they can substantially affect its suitability for potential development. And other than that, if you put municipal zoning regulations on top of it, for example, so zoning regulations typically impose building setbacks from front, side, and back of the property boundaries. Now, these restricted areas may occupy a relatively large percentage of a linear site total area, and therefore rendering the area unfeasible for development from a financial perspective. So, considering the site context is especially important, especially when you're evaluating small site areas or linear site areas. The next thing to consider, of course, is the site topography. So understanding a site's topography is essential in making good site planning and design decisions. Topographic surveys provide critical information about the site's biophysical context. There are three key attributes or three key attribute maps that can be derived from a topographic survey to graphically show variations in elevation, slope, and aspect. Normally, in a topographic map, you would see lines that represent the site's contour, and then you would see along those lines, along some of those lines, and numbers that indicate the particular line's elevation, and usually those numbers have a specific or they have a specific increments to them. The map that I'm showing you right now have an increment of 100 meters per classification. More on that later. So variations in elevation, slope, and aspect. So let's have a look at elevation first. Changes in elevation affect both drainage patterns, and visibility to and from the site. Elevation data, as I've briefly demonstrated before, are portrayed on topographic maps as contour lines and spot elevations. Sorry. For site planning purposes, an effective way to visualize topographic relief is to create a choropleth map of elevation. It's basically a colored contour map. The technical term for it, a choropleth map. To make it easy to understand, the map should have relatively few, between 5 to 9 elevation classes. So the darker lines here represent the different elevation classes. So no more than 5 to 9 elevation classes to just to sorry just to make sure that it's not going to just so that it doesn't complicate the map and it doesn't the range of existing elevations on and adjacent to your site determines the range of each elevation class. For example, if the highest elevation on the site is 400 meters above a local benchmark, usually above sea level, so 400 meters above a local benchmark and the lowest elevation is 250 meters, then the map should show a range of elevation of at least 150 meters. Now, the 150 meters is calculated from 400, take away 250, you get 150. So that's the range of elevation. And to limit the map's visual complexity, you can divide 150 meters by, you can divide the 150 meters into 6 classes. I mentioned anywhere between 5 to 9 classes. So 150 divided by 6 classes, you get a result of 25 meters. So the way you would graphically represent the changes in elevation is in 25-meter increments. And if you'd like to enhance the map's effectiveness, each layer, each increment would then be shaded or colored, typically with a spectrum ranging from cooler colors to represent lower elevations, so green, dark green, dark blue to represent lower elevations, and then warmer colors. So the green can transition into very bright yellow for higher elevations. Much like this, so darker greens, darker shades, or darker shades that represent the lower elevations, and then the lighter colors or the lighter shades to represent higher elevations. And then this chloropleth, once you've colored that in, or once you've got the contour map and the elevation lines and you colored it in, produced a chloropleth map, then these combination of information would give you an idea of the different slopes. So a site's suitability for roads, walkways, buildings, and other structures is, in part, a function of the existing slopes on the site. For example, in Hong Kong and cities like San Francisco, cities with relatively warm climates, development frequently occurs on sites with relatively steep slopes. Other than because of the geographical feature of or the inert feature of the geographical location. In contrast, locations with freezing winter temperatures, you would generally avoid development on steeper slopes, because in freezing winter temperatures, vehicle and pedestrian circulation systems on steep gradients can create safety hazards from icy and sloping surfaces. You get a nice big ice slide. Spatial variation in a site's elevation creates slopes that have both a gradient and an orientation. Slope gradients can be computed and easily mapped with most GIS and CAD softwares. The range of each map slope, uh, each each slope class depends on the intended use of the site and on the specific site and contextual conditions, which includes soil characteristics, vegetative cover, and of course, regulatory requirements. For example, to prevent significant environmental and aesthetic impacts, development regulations may prohibit construction on very steep slopes, for example, greater than 25%. Um, although I'll show you an example of some development in slopes greater than 25%. Soil stabilization and erosion controls may also be required to moderate steep slopes. To moderate steep slopes or to moderate if you want to develop on a steep slope, then you would need to treat the slope in a way, depending on the soil characteristics and soil stability and so on, just to make it nice and safe for development. But again, stabilization and erosion controls may also still be required on medium to steep slopes. 8 to 15%. That's a rather moderate slope. You would need to consider soil stabilization and erosion controls there. On the other hand, sites that are essentially flat, which have less than 1% slope, may have very poor drainage, because if it's flat, then water won't be able to flow. Or won't have a good runoff area. Now, each of these slope conditions warrants mapping, because these locations have significant site planning implications. So, just like the map that I showed you last week, this is a slope analysis, and in the slope analysis, there's a slope suitability table or slope suitability matrix that indicate where are the ideal spots for development. Now, yes, a little slope won't hurt, actually. I did mention that slopes greater than 25% are generally avoided to prevent environmental and aesthetical impacts, but extreme slopes can be fun too, fun to develop, and may present a challenge for some people. Two of the steepest slopes that I know of. One is in Queensland. This is near where I used to live. It's a 31% gradient. It's about 700 meters long. This street is about 700 meters long and 31% slope. Riding up it is quite a challenge. So you don't need to be riding up it. Walking up it is already a challenge. And then we have another slope which has gone viral over the last few months, I reckon, in West Java, and that's I'm not sure of the exact value, but some people have predicted that it's approximately 40%. It's a 40% slope, so that's very steep. But as I said, these extreme slopes are generally avoided, especially if you happen to be living or developing building in areas that have icy cold winters. because you don't want these extreme slopes to freeze over. That would of course cause a hazard to pedestrians and vehicles alike. However, we're in a tropical climate, so yeah, have as long as these slopes are stable, if you can stabilize them, well, build away. um, a slope's orientation, I did mention orientation, is also known as aspect. This is the compass direction that the slope faces, for example, north or northeast. Is the slope facing north or northeast? Variations in slope and aspect influence the daily seasonal solar radiation received by the site. In the northern hemisphere, for example, north-facing 10-degree slope will receive far less solar radiation than south-facing slopes of the same gradient. The figure on our screens demonstrate the influence of latitude on the intensity of solar radiation striking the Earth's surface. Now, because the slope faces away from the sun, and solar radiation striking a north-facing slope hits the surface at a shallow or an acute angle. Consequently, sunlight strikes the slope in a more diffuse pattern, delivering to the surface less solar energy per unit area. So this type of information you might use if you plan to have solar panels on your site, for example, where your slope is facing, where your site is facing. So site orientation can be useful in that. Another thing that is influenced by this aspect is the microclimate. So aspect influences microclimate by affecting the amount of solar radiation striking the site. As with other physical attributes, the importance of a slope's aspect depends partly on the proposed use of the site. At a higher northern latitudes, for example, south-facing slopes are better suited for siting buildings that will incorporate active and or passive solar heating. Conversely, a north-facing slope may be better suited for ski trail development in order to limit the melting of snow in late winter and early spring. That's if you have these extreme seasonal changes, of course. Slope aspect, like slope gradient, can be mapped with commercially available GIS softwares. Typically, aspect is classified using 8 categories: north, northeast, east, southwest, and so on. North, north, south, east, west, and then the lines, and then the orientations in between. These are portrayed graphically by either shading or color. So more shaded northern slopes, for example, in the northern hemisphere, are typically rendered with cooler colors or heavier hatching than are other slopes with greater solar exposure. But aspect in temperate areas like ours may not be too the differences in aspect may not be too extreme. Not because we have a flat surface or anything, no, but mainly because we have a relatively consistent sun exposure throughout the year. So this consideration may or may not be that influential to your site design and site design plans. Now, moving on to the next item on our list, surface geology is concerned with a structure, composition, and stability of the materials beneath and in some locations at the Earth's surface. Bedrock geology has a persistent effect on landforms due to the different rates of weathering that can occur on the soil parent materials. You can ask I think you can ask people who study geology and soils for that confirmation. But landform classification is useful in regional assessments, particularly for characterizing attributes that are difficult to quantify, like scenic beauty, for example. How can you quantify beauty? Oh, it's a level 10 beauty or a level 5 beauty and so on. But these land formations can help you with intangible values like beauty to become more tangible, so to say. Um, Landforms, in conjunction with vegetation, they define the kind of view sheds, and they can also increase visual quality. Um, Landforms also influence up to a degree microclimate. Of course they influence stormwater runoff and infiltration, and the distribution of certain of specific plant and animal species. Um, Soil formation, soil erosion, soil deposition are all natural processes that involve rock fragmentation and weathering. And weathering may occur unevenly because of the variations in bedrock's composition, chemical composition, and structure. An important attribute, of course, of surface geology is the depth to bedrock, kedalaman tanah keras bedrock. In some landscapes, bedrock can be positioned many meters below the ground surface. For example, ITS and the surrounding areas. What's that residential development near ITS? That area has a bedrock depth of about 12 to 16 meters below the surface. So other areas may have a shallower bedrock depth. So if excavation for building foundations or for other site structures is planned or required for a site, then you need to take this shallow bedrock, deep bedrock into consideration. You may have to involve a certain level of blasting or other methods to remove the topsoil. Of course, that would have great implications on the cost because on the overall project cost and budget, because the cost of excavating a cubic meter of rock is of course many times greater than excavating the same volume of soil. So that's where geological considerations come in handy. This is a sample of a geological map, and on a geologic maps usually show the age and distribution of different rock layers and other geologic materials. And Other than that, a geologic map usually includes information on topography and cultural elements such as roads to help orient the map user. Um, to produce a geologic map, um, you might have to conduct a site survey, but sometimes, if not most of the times, such geologic maps are readily available. So you can get them as secondary data from local governments, local authorities, or if you happen to know no, actually, just let's leave it at local government and authorities. Most of the times, you don't have to come up with a geologic map of your own. They're usually a readily available data. Sorry, they are usually a readily available data. Um, so uh, another thing. Excuse me for that. Um, another thing to note is that another thing to consider is um, local phenomenon such as volcanic activity or earthquakes. Now, volcanic activities, earthquakes, and landslides are relatively common events in some parts of the world. I know some parts of Indonesia happens to be situated just right on the ring of fire. Therefore, we have loads of volcanic activity, loads of earthquakes, and we also have a lot of landslides every now. We also get landslides every now and then. So these geologic disturbances, um, they're potentially they're potentially devastating hazards, and these are the things that you and these hazards you need to consider these hazards when planning new development in these areas in our areas. The locations of potential geologic hazards such as landslides, they're usually mapped by government agencies that are involved in preventing or minimizing natural disasters. So um, if you need to find out if you need natural hazard data, then contact the local disaster management bureau, um, and they should provide you with geologic hazard maps and so on. Now, um, water is another thing. Water circulates in the environment through precipitation, overland flow, through infiltration, storage, and evaporation or evapotranspiration. Groundwater moves by capillary action through porous spaces between unconsolidated sand, gravel, rock, and between fractures and faults in the underlying bedrock. No matter how small a crack is, water generally can infiltrate that. Um, so the water table, or the upper surface of the groundwater resource, generally mirrors the surface terrain, as demonstrated in this map that I showed last week. The contour lines indicate slopes, and the direction of the slope indicate where indicate where surface water would run off. So that's also known as the water table. Um, in landscapes where groundwater is the source of local municipal wells, groundwater pumping can substantially increase the depth of the water table as well. Um, so drainage is created by topographic variations. And these variations in turn influence plant distribution as well, because some vegetation enjoy a higher elevation than others. Now, the spatial correlation between vegetation associations and site drainage patterns is particularly strong in arid and semi-arid landscapes, where water is often the primary limiting factor on plant growth and distribution. Um, although groundwater vegetation linkage is more subtle in less arid environments, the continuous or seasonal saturation of soils can create wetlands. In coastal environments, brackish or saline surface and groundwater result in development of salt marshes and other distinct wetland communities. Um, so, with regards to water and water table hydrology in general, without on-site and off-site mitigation, um, urban development can have a significant impact on local and regional hydrology, um, because of course when you develop land, then you will modify the land surface, you'll modify the slope topography and so on. And some of these negative impacts include increased volumes and rates of runoff discharge, reduced time needed for runoff to reach surface waters, increased frequency and severity of flooding, and reduced stream flow during prolonged periods of dry weather. When you put hydrology and land development together, you get a whole different can of worms, as I mentioned just then about urban development and hydrology. Because land development, until relatively recently, generally involved the construction of buildings and paved surfaces that are impervious or nearly impervious. Now, these land cover changes substantially increase the risk of flooding, erosion, and other ecological impacts on properties downstream, such as the case or allegedly that is such as allegedly the case between Bogor and Jakarta, Jakarta being the downstream property. And surface water pollution associated with stormwater runoff reduces the aesthetic, recreational, and ecological value of rivers, lakes, and other water bodies. Consequently, stormwater management has become a highly regulated aspect of the land development process. You can refer to national standards and local regulations for that. Land development may also negatively impact groundwater quality. Now, this is especially problematic when local groundwater is a source of a community's potable water. So efforts must be made to ensure that an on-site wastewater treatment system and stormwater runoff don't contaminate these local or these community wells. Stormwater movements, infiltration, storage, and discharge are considered in the site inventory. The assessment of hydrologic conditions, they require an analysis of the site surface and subsurface features, including topography, vegetation, surface water distribution, land use, microclimate, and soil forming processes and deposits. Um, Surface drainage patterns and potential flood hazard zones are typically mapped. Um, in this particular map, you can already see where the water where water would generally collect, or pockets of water here and there. Maybe these pockets of water is best to be left alone, or left undeveloped. Um, Sometimes these areas may serve critical ecological functions, and therefore, yeah, therefore they make or they comprise major development constraints. Another important thing to consider is aquifer recharge areas. They're also very important to identify, and they need to be protected from development. The primary paths of groundwater flow and the locations of groundwater discharge to the surface are also important, particularly in more rural locations. Subsurface geologic characterizations may include the analysis of aquifer permeability, thickness, and discontinuities. Maps of groundwater and local geological conditions are particularly important in land use planning, of course, especially for rural areas without access to municipal water service. These site data can help determine potential sources of potable groundwater. So, moving on to soils. Soils are greatly influenced by climate, by landform position, and and of course the parent material. So to reiterate, climate, landform position, and parent material are key physical factors in soil genesis or soil formation. Soil genesis and morphology. I'm getting a notification of unstable connection, so I'm just going to cut off my video to save bandwidth for the time being. Other factors include growth, death, and decomposition of vegetation, microorganisms, and other biotas living above ground or within the soil itself. Soil properties are also affected by previous and current land uses. For example, a site with a history of previous industrial or commercial use may be contaminated with a handful of hazardous substances, and therefore investigation of a site's subsurface conditions is warranted. You need to, if you know that the particular parcel of land that you're developing used to be an industrial facility, or it used to be a nuclear power plant, for example, then you need to make sure that both the surface and the subsurface conditions are clean or safe or safe for development. If hazardous wastes are present on the site, then the costs of remediation can be quite substantial. For example, an example of this would be the removal of asbestos and any asbestos containing materials in old buildings. Asbestos removal can be quite expensive and hazardous. So if you take that if you take that analogy onto a parcel of land that used to be a factory or an industrial estate, then you can imagine how substantial the costs of remediation or normalization could be. Depending on the site's location and intended land use program, an inventory of soils may include attributes such as acidity or alkalinity, pH, pH levels, soil permeability, any erosion potentials, depth to seasonally high water table, and of course, depth to bedrock. Lastly, soils vary widely in texture, in fertility, permeability, and other attributes that influence plant growth and development. Soils that are favorable for plant health reduce the impact of pests and diseases, and therefore can reduce pesticide use. Soil erosion frequently occurs when vegetation cover is removed or vegetation cover is substantially damaged during site clearing and construction. Topsoil losses from prior agricultural uses or other erosive forces can also increase the costs of re-establishing vegetation on a site after construction. And when you re-establish vegetation on site, oftentimes the newly reintroduced vegetation need time to grow and settle in, and therefore you need to consider the time they need to regrow, to settle in, and help stabilize the topsoil. So moving on. A site's expected climatic and microclimatic conditions can also influence various site planning and design decisions, including building orientation and facade design, building siting and design of the siting and design of vehicular and pedestrian circulation systems. Microclimate also influences the selection and placement of plant materials and the overall design of stormwater management infrastructure. Now, seasonal and monthly climate data are generally available from National Weather Services. I know that the Bureau for Meteorological Activities, BMKG, they have quite extensive data sets, extensive climate data sets. I think they've collected and collated these data sets superbly. You can use that to help you with building the climate and microclimate profile for your site. Another thing to note is that local weather records can also provide additional information about weather conditions that can be expected in each season. Now, of course, with climate change upon us, these weather conditions can shift and vary greatly, but I think at least a general information of a general information or a general description of the weather conditions can still be helpful in preparing or in considering these aspects or these items. Relevant climatic data include, of course, temperature, maximum temperature, minimum temperature, what's the highest temperature, what's the lowest temperature, and things like, are there day and night temperature variations, and then humidity, high, low, and average humidity, um, wind, maximum or average velocity, and of course the direction, wind direction, monthly precipitation totals, if possible, 10-year maximums for a 1 hour and a 24-hour period that would be valuable for site development or site planning. Snowfall, if there is any snowfall, monthly total, maximum for any one day, maximum daily snowfall, so much like rainfall. Um, and then solar radiation, monthly averages, and of course, potential extreme weather hazards such as storms, cyclones, and typhoons, or even the tsunami potentials. Um, Natural hazards are another thing to consider. Natural hazards encompass atmospheric, hydrologic, geologic, and wildfire or bushfire events that because of their location, severity, and frequency, have the potential to adversely impact humans, their structures, or their activities. Natural hazards themselves aren't exactly problematic. Most of the times, they're a part of the natural cycle of things. It's a way for the planet to restore balance and such. However, these natural hazards, become disasters uh, when we take the potential impact into the equation. Um, Natural hazards present significant risks to human life and property, and therefore, this is something that we also need to consider in the site planning process. Um, in general, the built environment's vulnerability to hurricanes in particular is substantial because a large proportion of the world's population live near the oceanic coasts. Indonesia is, I believe, a country that has the second longest coastline in the world. I forgot what the first one was. Oh, the first one is, but we have a very long coastline. Why? Because we're an archipelago. So, with growing awareness of global climate change, the environmental, economic, and human impacts of natural hazards have become a very, very important public policy issue. So, um, we do have climate policies or disaster mitigation policies in place. Um, More policies and more regulations in one area than others. Depend, but in general, when building in Indonesia, when planning in Indonesia, natural hazards should naturally come into consideration. It should be one of the primary considerations because we're on the ring of fire. Okay, moving into the final proportion of today's session. Um, Development that fits the site is responsive to site context. Now, cultural features like historical features, aesthetic features, legal or economic features can create opportunities and constraints for the design of sustainable and livable places. Um, an assessment of cultural factors not only describes the site, but also analyzes its suitability for the site's intended use or uses. Um, I'm going to touch on the reuse on the reusing of land or land reuse. Now, adaptively reusing developed but underutilized land is a key principle of smart growth and sustainable design. But as I mentioned before, prior land use on a site can affect development suitability by increasing site preparation costs. And these site preparation costs can also include building removal or the removal of underground structures and the remediation of the site's soils. If a site was previously used for industrial or commercial purposes, as I mentioned, this could indicate that there are chemicals and other toxic wastes that remain on the site, either above or below ground. In front of you is a series, or in front of you are some pictures of the Butchart Gardens in Victoria, British Columbia, Canada, Victoria, BC. Would anyone care to guess what this park used to be?
Hmm,
Yep.
an industrial location, maybe, sir.
Well, yeah, because that's what I've been talking about. That kind of gives it away. It used to be an industrial location. To be precise, it used to be a cement factory. Um, more than 100 years ago, in the 1800s, in the 1800s, Butchart Gardens used to be a cement factory, and after the factory shut down, um, the the local administration decided decided to rehabilitate the site and build a botanical gardens on top of it. Uh, in 2000, in 2004, 2003, 2004, the Butchart Gardens celebrated their 100th anniversary. Um, so now it's 2021 now. So yes, it has been this garden is over 100 years old. But to think now that there are virtually no traces of its industrial past whatsoever, save for some features like the trolleys, the trolleys that were used to transport raw material for cement are still being used as planters today. And I think if I remember correctly, there are two chimneys. There are two chimney stacks that are left standing on the site, just to remind people of its industrial past. But if you walk through and you don't know, and if you walk through the gardens and you don't see the and you didn't see if you didn't see the chimneys or the trolleys, then you have and if you don't read the information board, of course, then you have no idea. There's no you have virtually no clue that this used to be an industrial site. Another example of adaptive reuse is, of course, the 798 Art Factory, which retains its industrial features and characteristics today. And again, when you talk about rehabilitating an industrial site, you need to consider the enormous costs of even a small toxic waste cleanup. And the enormous cost, this cost um, does have a chilling effect on the redevelopment of urban commercial and industrial sites. Other than toxic waste cleanup, there are legal and financial risks of purchasing and attempting to develop brownfield sites such as these. And usually, if we talk about the urban planning context in general, it's these legal and financial risks of purchasing and developing brownfield sites that, in a way, encourages urban sprawl by redirecting new development to greenfield sites on the urban or suburban periphery. So it's not because people don't see. Sometimes it's not because developers or people don't see potential in redeveloping an industrial site, but it's just the it's just that there are additional costs, additional risks, and additional considerations when additional considerations in place when you want to rehabilitate brownfield sites. This is especially so in older cities. Vacant industrial sites used to inhibit economic investments in surrounding neighborhoods. So brownfield sites, this is more so in Europe than it is here. These brownfield or industrial sites are used to sit right in the middle of, right in the heart of the city. Therefore, it just worsens the pollution and the economic and social impacts of, and thus impeding urban growth in some ways. However, I can remind you that if you decide to select a brownfield site for your case study or for your group work, it isn't. I encourage you to do so because so far, I think we've had mostly greenfield sites or very rural areas, rural sites to begin with. With regards to land use and such, you do need information on land ownership or land tenure, and usually these information is available publicly in publicly accessible databases. This is a shot of Singapore's One Map as a result of their One Map policy. Where you can view land ownership per parcel of land or per lot. Here, I just randomly clicked on a plot of land, and the map already shows the status of its ownership. It's privately owned land. And this is the lot number, and you can also buy title deeds from this One Map. And I reckon if you follow through the on-screen instructions and the on-screen links, you can also up to some extent view the land value of that particular lot. These records may be built or may include certified survey map of the parcel boundaries of the property lines, a history of land ownership and any deed restrictions or covenants associated with the property. I'm not entirely sure how comprehensive our local database is, but ideally you would want to you would want to find out the history of land ownership in the site that you're developing, just to make sure that the land is clear. It is clear who owns the land, um, and you may and you can also use that knowledge to help you anticipate any potential land ownership or land tenure related conflicts in the future. The online digital maps and associated metadata nowadays are increasingly available commercially, and you may find these through various government agencies. Um, I think we are Indonesia. Indonesia is currently moving towards a one map policy and something similar to this. But I think right now, if you want information on land tenure, land value, you might have to collect them from different sources, and then put them together to make a composite map or a composite data set, so to say. Of course, we also have land use regulations that restrict or otherwise dictate the direction we would take in developing a site. We do have national regulations, and then of course, but national regulations don't necessarily impact site development that much. Provincial regulations may have a certain effect on may have a certain degree of effect on how your site should be developed. But more so are the local plans and regulations, such as citywide plans, detailed spatial plans, and building regulations and such. And of course, other than these land use regulations, we also have standards, SNE, Standard Nasional Indonesia. We have the standards to use as planning and design guidelines. I can't highlight which standards that you will use exactly, because that really depends on what you're going to put on the site and so on. The built environment is a complex mosaic of private, public buildings, green spaces, and transportation and utility infrastructure. The location and condition of existing transportation and utility infrastructure also influence the siting, the positioning and orientation of new buildings, as well as other key site planning decisions, including the location of entrances to a site. I'm only going to highlight two aspects in this session. We'll continue with other aspects in our next meeting. So one of the first aspects, or one of the first attributes to consider, is transportation. In both site planning and architectural design, especially in urban contexts, established pedestrian and vehicular circulation patterns must be carefully analyzed and mapped. Different circulation systems, pedestrians, bicycles, or non-motorized transport and motorized vehicles, and volumes can be portrayed graphically by varying the color and width of the arrows. Google Maps is a good example of this. They show live, it shows live vehicular traffic, vehicular volumes in different road segments of a city. in different times, during different times of the day. Sometimes you see green roads, sometimes you see red roads, sometimes you see yellow, that sort of thing. Um, if you can, if you can map that, if you can map that and you and include that in your site inventory map, then that would be awesome to give you a good comprehensive look at movement patterns through and around the site. Um, Another thing to consider would be the average daily traffic volumes on adjacent streets and highways, if there are any highways. Um, this sort of data is available online. I just mentioned one source earlier, Google Maps. But you can also find them. But if you want a more comprehensive look if you want to have a comprehensive view of the, if you want a more comprehensive view of the traffic volumes, you can come visit the local municipality public works or traffic engineering department or the Department of Transit, Dinas Perhubungan. Existing conflicts between vehicles and pedestrians should also be mapped if there are any, because these conflicts or walkability challenges can often be mitigated through good site planning and design. So the locations of existing streets, driveways, transit stops, parking lots, and other infrastructure help you inform and helps you inform and shape the context of a site. Site planners usually have a certain degree of control or authority in determining how and where pedestrians enter a site. For example, and existing pedestrian, bicycle, and vehicular circulation patterns should influence the decision, these sorts of decisions. I'm sorry if my background is becoming a bit noisier. School has started. So I'm fighting for bandwidth as well. Failing to anticipate these existing circulatory movement patterns, or another term for these movement patterns or circulation patterns are, another term of it is called desired lines. So if you fail to anticipate the desired lines between existing and or proposed building entrances and other destinations, it may create new pedestrian and vehicle conflicts. You should also consider walking distances from specific destinations. And as a rule of thumb, you would typically limit or situate destinations in a way that it would only take a 5 to 10 minute walk from one destination to another or one function to another. Now, many land users require continuing inputs of resources such as potable water and electricity. With increasing attention to resource conservation and sustainability, these inputs may be generated on-site through cisterns, solar panels, wind turbines, and other small-scale technologies. In more conventional approaches to development, these resources are delivered to the site through the utility infrastructure. Um, these utilities may include gas, electricity, telephone, television, and of course, the internet. Where would we be without the internet? Um, Many land uses also generate continuing outputs, such as sanitary waste, that is either treated on site or collected and treated at an off site treatment facility. Typically, major utility lines are located within streets, rights of way, or within other circulation system corridors. A general rule of thumb is that if you want to plan utilities, such as electricity grids, water networks, just follow the roads. That's a rule of thumb. Follow the roads, follow the main roads for main lines, and local roads for distribution lines. Municipal utility systems typically deliver energy, water, and information to the site and removes waste and excess stormwater. On sites located outside of urban service areas, some of these gray infrastructure systems may be unavailable. Understanding where off-site and on-site utility systems are located is a key objective of site inventory. Now, this information is particularly valuable when you site new buildings, new circulation systems, and planning for open spaces that perform stormwater management functions. So these utilities, therefore, are a part of the whole green infrastructure. And then, of course, you need to assess the presence or the absence of such utilities to consider and consider both potential resource inputs and outputs. Another thing is that a survey of existing site utilities also typically includes location of utility poles, overhead power lines, fire hydrants if there are any, and utility boxes, electric or electronic transformers and such. Information about the capacity of each system is usually also provided. If you visit, or if you can get your hands on the local water supply map, then the map usually indicates the diameter of water distribution pipes. Usually, hopefully, they also you can also get your hands on sanitary or sewerage networks, as well as the overall transmission capacity of electrical and telecommunication data lines. So in short, I reckon because of current situations where we have long distance learning, we can't and we're not allowed to conduct on-site surveys. So we need to rely on secondary data that is provided by different agencies, different governing bodies, and different different companies or service providers. As I mentioned before, things like climate data is available from the Bureau of Meteorological and geophysical activities. Utility maps you can get from the national power company, the power grid. water and wastewater. I reckon from the PDRM. You can also get wastewater, sewage, stormwater runoff, and everything, and other things from the from the public works, from the local public works authorities. Spatial plans you can get them from you can get them from the local planning agencies and so on. So um, we would have to, of course, make use of these secondary datas, and I guess we just need to have a different approach to site surveys for the time being. But yeah, I reckon data availability nowadays are much better than it was before. So you should be able to get a good amount of data without having to actually go out and fetch them yourselves. But you still do need to determine, and I'm saying this to remind you of the group task. You still need to determine where you're going to develop your site and so on. But anyways, that is all I have for you this time. I was going to conduct another simulation with you today, some sort of site inventory, some sort of site inventory activity. But then I thought this is only partial. This is only partial of what I should deliver to you with regards to site inventory. So I'm going to leave it at that for the time being. But next week we'll talk more about other aspects of site inventory, like vegetation, street furniture, more into circulation, and transportation and such. And hopefully, and after we talk about the different components, the different aspects of or the different categories of site inventory, then we'll try and do a site inventory exercise. Just to give you an illustration of what I was planning, I was thinking of asking you to sort of pair up. So there are 19 of you. Pair up. So there's one group of 3 to pair up and conduct an individual site inventory of where you live. If you happen to live in a residential development, have a walk around your block and observe any of these aspects or components that I've mentioned: utilities, the circulation, the different modes of transport and such. If there are any regulations, maybe not, but focusing on the physical aspects of things, infrastructure, geological features, if there are any. Compile them into a site inventory table or matrix. You can scribble them on the map if you want to, and then you report or you trade. You swap data with your partner, and then your partner will present to you what you found out, and see if they can understand or they can have a grasp of they have a grasp of what you're of what you have done. So that's an illustration of what I was thinking in terms of site inventory simulation. We're not going to do it today, but we might do it next week. So yeah, I just need to finish up the guidelines to the activity, um, much like the exercise brief that I gave you yesterday for community development. Okay, so I'm still fighting for bandwidth. So, but anyways, do you have? Does anybody have any comments or questions regarding what I just talked about today? Otherwise, I think it's yes. Somebody unmuted themselves. No, no comments or questions.
I think no, sir.
Okay.
Yeah, for me, I don't have any questions yet. I think it's clear for me. Yeah.
Okay. Right. Thank you very much for that, for the comments. Yeah, I think what I've mentioned, what I delivered today is pretty straightforward, and we will pick up where we left off today next week. Hopefully by then, we'll be able to complete the entire site planning. Sorry, the entire site inventory sections, and therefore help you build a clearer picture of what you need to collect, what data you need to collect for the site planning process. Okay, thank you guys so much for showing up to today's session. For those of you who haven't marked your attendance, please do so. If you can't scan the QR code, I know there are some people who have issues with the QR code. The attendance code for today is 576742. And make sure you mark your attendance before the end of the day. So thank you very much. Thank you again. Have yourselves a great day today, and I'll see you all. I'll see you all next week. Good morning and assalamualaikum warahmatullahi wabarakatuh.